Okay, hi students, very good morning everyone, welcome to the session. Very good morning everyone, welcome all of you to the session, welcome all to the Om Institute platform. Okay. Very good morning, come on everybody, let everybody join quickly. So this is the next session on the BARC exam 2026 practice session, that is the revision through questions. I had a session earlier on control system, yesterday you had a session on power systems, and now this is signal and systems. Okay, so moving towards the next important area, that is the signal and systems. Okay. Good morning, Gwalaji. Yeah. So let's get started. By the time, others will keep joining, and let's directly start with the first question. Okay, as you know, this is revision through questions. If you followed control systems session, you might have understood the intent of the session, that we are not just taking a question, we are also revising the required background with it, of course with basic assumption that you have prepared for gate. So little bit the study is done, but a quick review session through questions is what we are following here. And have a look into the first question here. Evaluate the function integral 0 to infinity t square delta 2t minus 3. Okay, now there are two ways to handle this particular question. Okay. Number one is using the scaling property of impulse. Okay, where is this impulse going to be located? The impulse will be located at 2t minus 3 equal to 0, that is t equal to 3 by 2, 1.5. Okay, and because of this scaling factor, delta, see, normally we write down delta AT as 1 by modulus A. The area gets scaled for the unit impulse signal. Okay, good morning Rajendra. Okay, so we can write down delta 2t minus 3 as what is the scaling factor? 2. So 1 by 2 delta t minus, you have to write down the correct location of the impulse, and that is 3 by 2. Okay, 3 by 2. Okay, that is how it is. Okay, so then what is the question? The question becomes integral 0 to infinity t square into 1 by 2 delta t minus 3 by 2 dt. Is this within the limits or outside the limit? The impulse is at t equal to 3 by 2, and which is inside the limits. Because sometimes you have to be careful, if the integral given is outside the limit, then the answer would be 0. Sai Vikas says answer as D. Okay, so now what is going to be the answer? Okay, definitely answer will not be in t terms. Okay, because the answer will be given by f of t naught 1 by 2. What is the ft function here? T equal to how much? Okay, the answer is 1 by 2 f of t naught, that is t square. Okay, at t equal to the location of impulse, which is 3 by 2. Okay, which is 3 by 2. So the answer is 1 by 2 and then 3 by 2 square, and that becomes how much? 9 by 4 to 8. 9 by 8 is the correct answer. That is why D correct, none of the above. Okay, so you should not put down t equal to 3. The impulse is not at 3 and 3 square equal to 9. That should not be the correct answer. Okay, the correct answer is 9 by 8 here. Okay, otherwise, as I told you, what is one more alternate to handle this question is, okay, what you can do is, if you have any confusion with scaling or shifting, you can, eliminate the scaling shifting and suppose 2t minus 3 equal to some variable p, and then solve accordingly. If that is the case, what is t equal to? Or first of all, how much will be 2 dt? 2 dt is p, and dt will be equal to dp by 2, number 1 point. And what is t equal to? P plus by 2. Then the question will look like, will the limit also change? Yes. If t equal to 0, limit will be minus. T equal to infinity, infinity minus 3 will be infinity. Okay, then t means p plus 3 by 2 whole square delta p dp by 2. Then what will be the answer? This impulse is at origin. This impulse is at origin. So in this function, p equal to 0 will be substituted. Then also the answer will be 3 by 2 square. Answer is 9 by 8. Any of the choice you can take to solve this particular question. Okay, then we have the next one here. Which of the following signal is a periodic signal? Which of them is periodic? Okay, which of them is periodic? Now, look into this one. Look into this one. E power, I'll start with continuous domain question, and it is MCQ. BARC means MCQ, only one option correct. Okay, e power, but I'll explain all the options. If you break this, na, e power minus e power jt, e power minus t, e power plus jt. Now in continuous time domain, okay, if it is continuous time domain, any e power j omega t or cos omega t or sin omega t. Okay, what you know about continuous domain? Any of the signal individually is periodic. Okay, with the period 2 pi by omega. Okay, but okay, this part is periodic, I agree. Okay, but what about this part? E power minus t, this is aperiodic, na, exponentially decreasing function. That too given for all values of time. Okay, this is the exponentially decreasing function, e power minus t. This does not have any repetition, it continuously decreases only. Okay, so this is aperiodic. Correct answer, yeah, Sai Vikas and Govind has given the correct answer, C. Now, if you see the signal x to t, okay, cos 2t, cos 2 pi t alone is periodic, sin 3t again periodic. Any individual sinusoid is periodic in the continuous time domain. But when you talk about addition of two sinusoids or two periodic signal, you must always check the ratio of time periods or ratio of frequency. Okay. The ratio of time periods or ratio of frequency, anything that has to be rational number. So what is the ratio of frequency? 2 pi upon 3, and because a pi is left, this is not rational number. Okay, and whenever the ratio of time period or ratio of frequency, anything you check, if it is not rational number, the signal is aperiodic. Second also aperiodic. Now in the dt domain, same thing. When you say in the dt domain, okay, e power j omega n, cos omega n, sin omega n, take it, they are not always periodic. They are periodic if 2 pi by omega is rational. They are periodic if and only if 2 pi by omega is rational, otherwise they cannot be periodic. Okay, so here if you see what is the value of omega, e power j omega n, omega equal to 1, and then what is 2 pi by omega? Will be 2 pi. 2 pi is not rational, it is irrational number. Okay, so the given signal is aperiodic. First also aperiodic. Okay, so only answer left is C. But yeah, again, if you check 2 pi by omega here, that is 2 pi upon 5 pi, and that is what is 2 by 5. 2 by 5 is what? The ratio of integer. When I say rational, what do you mean by rational? Any number which can be expressed as the ratio of two perfect integers. So yes, 2 is also an integer, 5 is integer, pi got cancelled. Okay, so this one is rational. And because this is rational, the given signal is periodic. So which of the option is periodic? Option number C. Okay, if I asked you the period, okay, this is periodic, but what period? Okay, what period? Okay, one more concept I'll add here. Okay, is the period equal to 2 pi by omega, which is 2 by 5? Because in discrete domain, the period has to be integer. Okay, the period has to be integer. It cannot be 2 by 5. 2 by 5 is not integer. It is periodic. Then what is the period we take? Okay, period is taken as any integral multiple of 2 pi by omega. If 2 pi by omega is not an integer, take the integral multiple, because if the value of the signal repeats at 2 by 5, it will also repeat at 4 by 5, 6 by 5, 8 by 5, 10 by 5. Or I can say this way, 2 by 5 into 5. If I take fifth multiple, okay, 5 and 5 will cancel, answer will be 2. The period will be 2. Again I repeat, the value of the signal repeats at 2 by 5. But 2 by 5 is an invalid time in discrete domain, because discrete time means what? Only integral values of time are allowed. 2 by 5, 4 by 5, 6 by 5, 8 by 5, 10 by 5. 10 by 5 is how much? 2. Okay, that is the correct period. Okay, so if I ask you the period also, then you should be able to say the correct answer too. It should not be 2 by 5. If it was continuous domain question, then the period can be 2 by 5 also. Continuous time means it can take any value. Discrete time means only integer allowed. Next question. What is the RMS value of the given periodic waveform? Okay, another question on periodic waveform where I am talking about the RMS value of the periodic waveform. Okay, now what is RMS value? Root mean square value. The root mean square value of this function ft, RMS, means under root of the mean square value FMS, or under root mean square value also is known as the average power, is also equivalent to the average power in the signal. Now for any periodic waveform, how do you calculate the average power? Average power is given by energy in one period divided by time period. For a periodic waveform, this is a simple way, shortcut. Energy in one period divided by time period. Energy contained in the signal in one period divided by the value of the time period. Okay, how much is the time period here? Okay, so time period, if you mark from the beginning of this positive cycle minus 0.3 and then next positive cycle at 3.7. Okay, so this becomes the time period 4, 0.3 here and 3.7 this side. Okay, the time period is 4. Okay, then what is the energy in rectangular waveform? Amplitude square into duration. Okay, first you have a rectangle, amplitude 4 square into duration minus 0.3 to 0.7. Okay, this much of the duration is 1 plus next amplitude minus 2, although 2 same only. Okay, and then what is the next, this much of the duration? 0.7 to 2.7 is 2. Okay, amplitude square into duration whole divided by time period, which is 4 here. So net answer is 4 square, 16 plus 8, this is 8 divided by 4, 24 by 4, 6. 24 by 4, 6 it should be. Okay, then what is the average power? It should be given by root 6. Okay, check the calculation once. I think okay only. Amplitude square 428, then amplitude square 4 to 60, 4 square 16. This duration is equal to 1 unit only. Okay. Energy in one period by time period is the average power, and then the final answer is under root of this. Okay, that is root 61. Okay, next question. The input output relationship of the following two system is given. Y1t is x of 2t, y2t, sorry, this is y2t. Two different systems are given, and sine of xt. Which of the following statements is true? Okay, now x2t, time scaling, any type of time scaling, x of at is non-causal. It is always non-causal in case of time scaling. Whether it is expansion or compression, anything. You can directly also see here, if you put t equal to 1, you get x2. Okay, output at 1 depends on input at 2, future. Okay, so non-causal. Okay, so the first one is non-causal. Second one, now y2 is sine. Now sine has something to do with linear or non-linear nature, but sine of xt, what value of input required? If output is required at t, input is required at t only, same instant. Same instant means present, okay, current time. Okay, so only present means causal. Okay, so y1 is non-causal, y2 is causal. Option number A, simple one. Okay, option number A, simple one. Yeah, MS course you have a chance. Okay, MS course you have a chance. But since IN branch, it's not easy, na? IN branch, I have to check. I'll just connect me in Telegram. If it was easy, then definitely you had the chance. IN, I'll have to verify once. I'm not 100% sure about your answer right now, Omega. Just message me in Telegram once. I'll give you the confirmation. Confirmation means whether it is possible or not. Confirmation to nobody can give right now before the results. Okay. Yeah. Next one. Next question. The output of a system is given as yt equal to x0 minus xt, where xt is the input and some initial value x0 has been taken. The system is linear and time varying, non-linear and time varying, linear time invariant, non-linear time invariant. Okay, what type of system has been given? See, this is mostly a direct question. You can write this way, minus xt plus x0. x0 is what? Some initial value, constant value is given. Okay, this is of the form y equal to mxt plus c. Okay, linear means what? A straight line. Input versus output has to be a straight line passing through origin. Okay, whenever you have y versus x as a line, as a straight line passing through origin. Y versus x, whenever it is a straight line passing through origin, okay, then only it is linear. Okay, so this one is clearly non-linear. This one is clearly non-linear. Now, what will change the time invariance nature? Whenever there is any change in time argument or any separate function of time, there is no separate function of time, there is no change in the time argument, nothing. This is time invariant, non-linear and time invariant. Okay. Okay, there is a procedure to verify time invariance, but not required. You can watch my earlier classes on YouTube where I've clearly explained you. Okay, if there is any separate function of time, even in the champion series, I've taken the video onto this and explained. If there is any separate function of time, it is m constant minus xt actually. Okay, or if there is any change in the time argument, then the time invariance is affected, otherwise not. Next question. Simple one. Convolute xn equal to u of n plus 1. Okay, hn equal to u of n minus 3. Now it is discrete time domain. First, what is the result you have to use is un convolution un is how much? Un convolution un is given by n plus 1 times un. Okay, options are in RAM signal, so I'll write it in the form of RAM signal, r of n plus 1. Un convolution un is r of n plus 1. Okay, right. Un convolution un is r of n plus 1. Okay, r of n plus 1. Okay, so now time shifting has to be applied. 49 means probably around 1000 you can get the rank, so something decent you will get. Okay, money. Guys, I'll tell you if you have any doubts with respect to your marks or anything coming up, what PSUs or what IIT or NIT you may get. I'll request you to message me in Telegram separately. The intent of this session is practicing more on BARC question, or else you can message me in Telegram. Otherwise, around the result time, anyways, I will take a guidance session. Okay, because right now you have tentative marks, some MTA, some questions might change. Okay, you only have the knowledge on the basis of rank predictors, but you don't have your correct rank now. Okay, so let the result come. During the result time, I will take, just after the results are declared, we'll take a proper post-gate guidance session. Okay, where, you will come to know your possibilities. Okay, what you can get at your rank. Okay, un convolution un is r of n plus 1. Okay, so here now the question is u of n plus 1 convolution u of n minus 3 will be equal to how much? Now, when any of the signal is time shifted, the output is also time shifted by same amount. Both are shifted. Output will be shifted due to both n plus 1 minus 3. This n plus 1 minus 3 and plus 1 anyways is separate. So, the net answer has to become how much? 2 minus 1, 2 minus 3, n minus 1, r of n minus 1. Option number B it is actually. Option number B. No problem, Mani. You can ask also, but I'm just telling. It's not that you can't ask right now, but the session will be deviated. So you ask me in Telegram, we can have a more detailed discussion. That's what I meant. Okay. R of n minus 1. Because I want to cover as many questions as possible, different topics. For a time invariant system, the different combinations of the input xn and our corresponding output yn, input xin, output yin given, the arrow indicates the position of xi0, yi0, arrow is origin, we already know it. Now see, for a time invariant system, they have clearly mentioned the system is not linear, or may be linear, may not be linear, nothing is told, so we can't assume linearity. Okay, it may be linear, it may be non-linear, right? Okay, but it is time invariant. Okay, what is the question? Okay, so some different combinations x1, x2, x3, x4, 4 inputs, their corresponding outputs are given. Okay, find the impulse response of the system. Find the impulse response of the system. Impulse response of the system. Okay, impulse response of the system. Come on, let's find out the impulse response of the system. Impulse response of the system. Let's do it. Okay, the system has to be taken as time invariant. We don't comment anything on linearity. Now see here. Okay, If it was linear, by chance, if it was linear, then this would have helped me, because this is the signal non-zero only at origin. This is like 3 del n. Output to 3 del n is 3 hn. If it was linear, because what we know, the impulse response is, impulse response means what? Output of the system to which input? To unit impulse input, delta n. Okay, if delta n has the output hn, 3 delta n has the output 3 hn. So this is 3 hn. If it was linear, okay, this is what scaling. Linear means scaling and additivity. Okay, so when input multiplied by 3, output multiplied by 3 if it was linear. Okay, so I should not be using it because linearity is not mentioned. But time invariance. What is time invariance? Okay, time invariance means if xn gives the output yn, x of n minus n naught, a time shift in the input should result in the similar time shift in the output, y of n minus n naught. Okay, y of n minus n naught. X of n minus n naught, output will be y of n minus n naught, correct? Y of n minus n naught. So here you look into this input, x4. Okay, you know, we need to find the impulse. Impulse response is output due to the impulse, and impulse means a 1-point signal. Here the impulse is available at n equal to 2, but no problem. If you left shift this, what is going to happen? Okay, if you left shift x4 by n plus 2, okay, will that be equal to impulse or not? Yes, na? If you left shift means you will bring this here, and the signal which is 1 only at origin is impulse signal. So x4 n plus 2 is delta n. Okay, now, right, okay. x4n has the output y4n. Okay, using the time invariance nature of the system, okay, what is this? x4n plus 2 has the output y4n plus 2. This is more of concept question. I have not given the options for this, but just try to understand. Concept wise, this is a good question. Plus 2. Okay, x4n plus 2 means delta n. Delta n has the output known as hn. So what is the impulse response of the system? y4n plus 2. Okay, the y4 also has to be left shifted by 2. Now when you left shift this signal by 2, okay, when you left shift, okay, so 0, 3, 2, 0, 0, 0. Okay, there will be one more 0, na? The arrow will come up there if you left shift the signal. 0, 0, 0, correct. This has to be the impulse response of the system. Okay, this has to be the impulse response. Concept wise, a good question. Concept wise, a good question. Okay, so I'll give you a homework here. Find the impulse response hn for the previous data, for the previous question, if system is given as linear. Already I gave you the hint, if the system is given as linear, but not time invariant. Time invariance, suppose not mentioned, you forget the time invariance. If the system was only linear, if the system was only linear, okay, then what is the impulse response for the previous data? Okay, you please try it. I already gave you the hint. You can watch the video 2-3 minutes back. I told you about this x3 combination. That will help you. Okay. Next. Consider the following cascade of two subsystems with the impulse responses. h1t equal to minus h2t equal to 1 by pi t. What is the step response of the overall system? Now, first of all, when we talk about overall system, dear students, when we talk about overall system, please pay attention here. If I consider this as my overall system, what is the overall impulse response is given by h1t convolution h2t whenever two systems are cascaded. Okay, a cascade combination is given. But what is h1t? See, remember, this question actually in time domain would be little tedious. h1t is 1 by pi t, and 1 by pi t is nothing but the impulse response of Hilbert transform. Okay, 1 upon pi t is the impulse response of Hilbert transform. Okay, Hilbert transform. Okay, Ji. Okay, then for the Hilbert transform, what is the H1 omega? Let us solve this question in frequency domain. Fourier transform. Hilbert transform defined by minus j signum omega. Okay, minus j signum omega. Right? Now, what is going to be the h of omega? Let us find out the h omega. Two systems are cascaded, impulse response convoluted, frequency response will be multiplied, h1 omega into h2 omega. Or what is h1 omega? What is h1 omega? Minus j signum omega multiplied by h2 omega. What is h2 omega, by the way? h1 is minus h2. So in the frequency domain also h1 omega is minus h2 omega, or h2 omega will be minus of h1 omega. Minus of h1 omega means plus j signum omega. Now what is this? Minus of j square into, what is the square of signum omega? Okay, what is the square of signum omega? What is the square of signum omega? That way you can think, okay, then you will get the answer. What is the square of signum omega? Okay, minus of j square is minus 1. See, what is signum omega? 1 on the right, minus 1 on the left. When you take the square, 1 square is 1, minus 1 square is also 1. So signum square is, net answer is plus 1, minus of minus and 1. So plus 1 is the answer, dear. Okay, so what is the answer here? Okay, I'll take it here again. What is the h omega obtained? H omega obtained is 1. So what is the net ht? 1 is the Fourier transform of which? Delta t. Okay, final impulse response is delta t. Now overall step response. Okay, what is the meaning of step response? Okay, the output due to unit step input. Okay, the output due to unit step input. Step response is given by output due to unit step input. Unit step convolution with impulse response. This is how we calculate output, na? Input convolution impulse response. Okay, but what is ut convolution ht? Ht here is delta t actually. Ut convolution delta t is ut. Okay, is ut. These two systems are basically inverse of each other, you can say. So whatever xt you apply, same will be the output. Output will be, if you apply unit step, output will be unit step only. Step function, option number B. Correct answer, Govind. Answer is B. Sai Vikas and Mani recheck. Impulse function is the net impulse response, but not the step response. Okay. Okay. Please check it out. Any doubts, please let me know. Any doubts, please let me know. Yeah, again a good question only. So as I already told you when I had the session on BARC preparation strategy, some questions can be straightforward, some questions can be good also. Some questions are even lengthy in BARC that we have seen, but you have to be very choosy first while taking up a question. You should first try to solve all the questions which can be solved in less amount of time. Next question here. If the signal xt shown in the figure A is fed to a LTI system having the impulse response ht shown in the figure B, what is the value of the DC component present in the output yt? DC component of the output yt. Okay. Now DC component, now see, of the output yt. Yt has some Fourier transform y omega. Okay, this DC component means, okay, the y omega at what is DC frequency? 0, omega equal to 0. That means I need y0. And what is y0? What is y0? You don't have to calculate the Fourier transform, because the y0, the value of the Fourier transform at 0 frequency is nothing but integral of the signal, integral yt dt, or area of yt. Okay, equal to area of yt. Now, here it's more out of convolution question. Okay, yt is what? Area of yt, na? What is y of t? Y of t is given by x of t convolution with h of t, and whenever two signals are convolved, their areas are multiplied. Area of yt is given by area of the xt whole multiplied by the area of ht. The area of ht. Okay, so area of xt, area of ht. Okay, what is the area of xt? Area of x multiplied by area of h. Area of the xt signal. Okay, triangle signal half into base. Base is how much? -1 to 1, 2 unit. Height is given as 2 unit. Signal h is the signal, base into height. Base is 2, height is 1. So net answer, this is 2 cancel 2, 2 into net answer is 4 actually. Net answer equal to 4, option number D. Option number D. Okay, 4. Correct answer, Shanmukh. Okay, correct answer, Sai Vikas, Money. Right, D, 4. Next one. For an energy signal ft and its time shifted version ft minus t, okay, we choose the correct option. Okay, time shifted version. Okay, amplitude spectra and phase spectra has to be compared. Okay, if ft has the Fourier transform f omega, time shifting ft minus t naught or ft minus t has the Fourier transform which is only phase shifted, because a phase term, exponential term e power minus j omega t gets multiplied. Okay, now if you want to understand the effect clearly, what is f omega? F omega is broken as modulus f omega e power j angle f omega. This is magnitude spectra, this is phase spectra, magnitude or amplitude spectra. Okay, now again if I substitute the same f omega here, it modulus of f omega e power j angle f omega e power minus j omega t. Okay, the exponential terms, if you multiply, so net power is e power j angle f omega minus omega t. So if you look into the original signal, what is the amplitude spectra? Same, modulus f omega. Phase spectra is shifted, angle f omega minus omega t. Okay, so the amplitude spectra are identical and phase spectra are not identical. Phase spectra are different. Answer is B. Amplitude spectra identical, phase spectrum is different. The change in the phase part. Every time shifting, this what? Shift in time is phase shift in the frequency domain. Okay. Yes, Sai Vikas, Govind, Mani, correct answer B. Correct answer is B here. If ft is a real and odd function, then its Fourier transform will be how much? A symmetry based question. Then its Fourier transform will be how much? For a real and odd function, the Fourier transform is pure imaginary and odd function. Pure imaginary and odd function. If a signal real and odd, Fourier transform pure imaginary and odd. Okay. If signal real and even, next common result they can ask, if signal is real and even, then Fourier transform will also be real and even. Okay. One more important point, if the signal is only given as real, very important, then the Fourier transform is what? Then the Fourier transform is conjugate symmetric. What is conjugate symmetric? F of minus omega is conjugate of f omega. Right now, the signal is real and odd, Fourier transform is pure imaginary and odd. All right. Consider the function h omega equal to h1 omega plus jh2 omega, where h1 omega is odd, h2 omega is even. Then the inverse Fourier transform of h omega is what? Okay, think about this. Right. Yeah, for the previous question, Shanmukh, Sai Vikas, Rajinder, correct answer. Now think about this. Slightly better question. Okay, but around symmetry property only. Around the symmetry property only. Come on, get hold of this and answer this. Yeah. Let's do it then. Let's do it. What is given? H of omega is given as h1 omega plus jh2 omega. h1 is odd, h2 is even. Odd and even, first what we will do is we will solve h minus omega. Let's apply minus omega throughout. Then what is the right side? h1 minus omega plus j h2 minus omega. Okay. Then this h of minus omega. What is h1 minus omega? What will be h1 minus omega? h1 is odd function. So minus h1 omega plus j. What is h2? h2 is even function. So h2 minus omega is h2 omega, even symmetry. Okay. Now what is this h minus omega? If you take minus outside, okay, what will happen? h1 minus jh2. Let me write this way. h1 minus jh2 means conjugate of h omega. Conjugate of h omega. Okay. Now you see, correct. What is this h omega? H minus omega is minus of modulus h omega. That means it antisymmetric. The signal is pure imaginary. The signal is pure imaginary. Option number C. When the signal is pure imaginary. Option number C it is. Okay. When the signal is pure imaginary. Okay. Conjugate antisymmetry. See, for both the previous discussion and this discussion, okay, what is the fundamental, basic fundamental that is required is if ft has the Fourier transform f omega, f conjugate t has the Fourier transform f minus omega whole conjugate. Okay, that means when you talk about a real signal, what is real signal? The conjugate and the signal are same. F conjugate t equal to ft. That means f minus omega conjugate equal to f omega. Or I can write this way, f minus omega equal to f omega whole conjugate. This was conjugate symmetry. Okay, if a signal is imaginary signal, okay, what is the property of any imaginary value? The conjugate of it, the conjugate of ft is minus of ft. Whenever a number is pure imaginary. Okay, so then what do I say? F minus omega whole conjugate equal to, right side also minus ft, so minus f omega. So what will I say here? F minus omega is minus of f omega whole conjugate, and that is what is conjugate antisymmetry. That is what is conjugate antisymmetry. Okay, conjugate antisymmetry. Okay, so that is what it is, conjugate antisymmetry, pure imaginary function, pure imaginary. Okay, answer has to be C. Rajinder, correct. Govind, recheck it once. Next question here. Which of the following can be the magnitude of the transfer function mod h omega of a causal system? Causal system. See, what is the concept to be applied here? See, what is causal signal? Causal signal means ht will be 0 for t less than 0. It will not go to the left. It can be anywhere on the right. Okay, but not on the left. Which of the following? It has to be solved by a logic and property only. Which of the following can be? Okay. Which of the following can be the magnitude response, the magnitude of the transfer function? Now simply remember the point that if you think about which options, option number A, B, C, option number A, B, C are band limited, right? What is band limited? Okay, what is band limited? Okay, when they have finite number of frequency band, band means frequency band, okay, it does not go to infinity, simple point, it does not go to infinity in the omega axis. Okay, ABC are band limited, but Fourier transform is band limited when the signal in time domain is time unlimited. Time unlimited means the signal is defined for all times minus infinite to infinite in general. Okay. Right. So definitely ABC cannot be the correct answer, because if ABC are band limited in the time domain, the signal will be time unlimited, ranging from minus infinite to infinite, but causal signal cannot go to the left side. Okay, causal signal cannot go to the left side. So only possible answer, okay, is D here. That's what we have to think about, which of them can be the magnitude response, okay, of a causal system. Okay, next one. Let's go to the next question. A signal xt has its Fourier transform shown in the figure. Find the value of integral mod xt whole square. Okay, what is this? This is known as the energy formula for a signal. Okay, and we have to go for Parseval's relation, because xt is not given. Okay, its Fourier transform is given. So this is a direct question on the Parseval's relation. This one is the direct question on the Parseval's relation. Okay, where you will write down energy to be given by in the time domain integral minus infinite to infinite modulus xt whole square, okay, is also equal to 1 upon 2 pi integral minus infinite to infinite modulus x omega whole square d omega. Okay, now this will be 1 upon 2 pi. Now integral mod x omega whole square. Okay, that is area under square of x omega. What is x omega? Okay, area under square of triangle is what? X omega is okay, area under square of triangle is always given by some basic energy results. Okay, a square into d by 3. Area under square of triangle is given by the relation amplitude. Like for rectangle, amplitude square into duration. For triangle, it is amplitude square into duration by 3. What is the amplitude? 4 into duration minus 4 to 4. How much? It becomes 8 is divided by 3. Okay, so right answer is becoming how much? 1, 2 you can cancel. Okay, so how much it is? 8 into 16 only divided by, no, I got one cancellation of 2. So then it is 8 into 8 only. Yeah, correct. 64 divided by 3 pi. Answer is D. Answer is D. Yeah, correct answer. Mani and Sai Vikas. D. D is the correct answer. 64 by 3 pi. Okay. 64 is divided by 3 pi. Next question. The Fourier transform of a rectangular pulse. Okay. Just a statement. Fourier transform of a rectangular pulse is how much? I'll write down the formula also. Okay. Normally I define the rectangular pulse as the rect of t by t, a standard rectangular pulse, which I take as a symmetric rectangle, which I define it as the symmetric rectangle from minus t by 2 to t by 2. That is total width of t. Minus t by 2 to t by 2. Okay, and suppose height is 1. Okay, yeah, correct. Firstly, you should know that the answer is a sinc function or a sampling function. Okay, rect t by 2 has what Fourier transform? Rect t by 2 Fourier transform is given by t sampling omega t by 2, or also equal to t sinc in the form of sinc function omega t by 2 pi. Okay, or omega by 2 pi, you can call it in the f also. Okay, right. Okay, what is this sampling function? When I use sampling theta is sine theta by theta. Okay, when we use the sinc notation, sinc theta is defined as sine pi theta divided by pi theta. Sine pi theta divided by pi theta. Okay, and sinc theta is simply equal to sampling pi theta. Correct, na? Inside sampling, if you put pi theta, you get sine pi theta by pi theta, which is sinc theta. So sampling pi theta is sinc theta. So sampling theta is sinc theta by pi. That's what I have done there. Okay, so anyways, answer, they're asking only the nature here. So nature is sinc function. The nature is sinc function. Okay, then the next question. Consider a signal defined by xt equal to e power j20 for mod t less than 1 and 0 for mod t greater than 1. What is its Fourier transform? A signal defined, okay, some signal defined only for mod t less than 1. Mod t less than 1. Okay, mod t less than 1 means what? Mod t less than equal to 1 means t can be from minus 1 to 1. Na? 0 to 1 or 0 to minus 1. Both the side magnitude when you take it is less than 1. Okay, so the t can be from 0 to 1 also, 0 to minus 1 also. Okay, that is minus 1 to 1. Okay, that is minus 1 to 1. Okay, correct answer, Sai Vikas. So answer is from minus 1 to, you have to, define a signal which is some exponential phase term given. Okay, only from minus 1 to 1. And whenever you need to restrict a signal under 2 points minus a to a, okay, you can use the rectangular function. You can use this rectangular window. How I can write down this given signal? I can write down the given signal as how much? Suppose you take e power j10t and write down this way, e power j10t multiplied by 1 or 0. E power j10t into 1 will be e power j10t, e power j10t into 0 will be 0 only. Okay, 1 for mod t less than 1, that is minus 1 less than equal to t less than equal to 1, and 0 otherwise outside this interval. I'll simply write otherwise. Now, what is this signal? This is what is a rectangular signal, a signal which is 1 from minus 1 to 1. If I take minus 1 to 1, total width will be 2. Okay, total width will be 2. If I alone have to draw this much of the part, okay, if I have to alone draw this much of the part, you will draw a rectangle from minus 1 to 1, okay, having the total width which I called it as 2. So this is what type of signal? Rect of t by t. What is the total width? 2. Okay, so that means given signal can be written as what? E power j10t multiplied by rect of t by 2. Rect of t by 2. Now what is the Fourier transform for rect t by 2? What is the Fourier transform for rect t by t? 2 sampling omega t by 2. 2 sampling into omega t by 2. T equal to 2 I have put. So this answer will be 2 sampling omega. This answer is simply 2 sampling omega. Okay, now when you multiply e power j10t, exponential term in the time domain. See, we already saw one question on time shift. Okay, shift in time leads to phase shift in frequency domain, exponential term. Similarly, when there is the phase term or exponential term in the time domain, it leads to frequency shift. Okay, Fourier transform frequency shift property. Okay, and that is given by 2 sampling omega minus omega naught, opposite sign. How much is the shift here? How much is the phase term there? 10t here. So I'll write down omega minus 10 here, opposite sign. Okay, 2 sampling omega minus 10 is the answer. Okay, and sampling theta is sin theta by theta. So sin omega minus 10 upon omega minus 10. Sin omega minus 10 upon omega minus 10. Option number A. 2 sin omega minus 10 by omega minus 10. Correct answer. Mani and Govind as well. A. Sai Vikas correct. Yes, Mani correct. It is the frequency shift property that has to be applied in this question. Okay. What is this frequency shift in general? If you have e power j omega naught t multiplied by a signal xt, signal xt had the Fourier transform x omega, which now becomes x omega minus omega naught. X omega minus omega naught, right? Okay, next question here. A signal mt band limited to a maximum frequency of 20 kilohertz is sampled at the frequency fs to generate st. An ideal low pass filter having the cutoff frequency 37 kilohertz is used to reconstruct mt from st. What is the minimum of fs required, minimum value of fs required to reconstruct mt without any distortion, without any aliasing? Admit cards mostly next 3 to 4 days I believe should be there. Today is what, 3rd? Mostly next 3 to 4 days it should be there. Okay. Let's do it. A signal mt, now see here, a signal mt which is band limited to 37, band limited to a maximum frequency of 20 kilohertz is sampled at fs to generate st. Achha. Now first of all, what is the signal mt? It is band limited okay, with the maximum frequency, okay, the maximum frequency component is 20k, 20 kilohertz, okay. Now, if it is band limited, let's say it has some Fourier transform, m omega, and suppose this is the Fourier transform, for example, okay, maximum frequency is 20 kilohertz. Okay. I can assume any type of Fourier transform, but which is, let's assume a triangle, rectangle, any simple curve. Okay, write it in the F domain. Okay, so suppose it has the Fourier transform MF. Okay, this is the F domain, and this is going to be 20 kilohertz. Okay, this is going to be minus 20. Okay, suppose this frequency is in kilohertz only. Okay, now this is sampled at a particular frequency Fs, kilohertz, to generate St. Okay, how do you sample? Multiply the given signal mt by the periodic impulse train Pt. Okay, by the periodic impulse train Pt. Okay, and in the frequency domain, if you want to do the analysis in the frequency domain, then S omega is given by how much? It is obtained as 1 by 2 pi m omega convolution with what? Convolution with p omega. Okay, m omega convolution with t omega. And finally, on solving, we get 1 upon Ts. This is something about sampling you must know. M omega minus k omega s. K equal to minus infinite to infinite. That means the spectrum of the sampled signal, is given by 1 upon Ts. Okay, assuming ideal uniform sampling, it is, if you open for different values of k, suppose you take k0 only, you get m omega, then m omega minus omega s, and etc. Okay, all the right and left shifted version. Now, if this is m omega or mf, again we'll solve it in mf. What is there? Okay, let's take an extra slide here. A question on the concept of sampling only. Suppose let's take in kilohertz and let us draw SF here. Okay, what does SF contains? Okay, I have written the formula in omega domain. You can convert to F domain. What is the intent that you have to understand? Even this magnitude part will not be important. Okay, because it is only talking about the filtering and construction part. M omega or MF. Okay, what is MF? This is 1 MF. Okay, minus 20 to 20. Okay, spectrum from minus 20 to plus 20. Now, the next has to be right shifted by Fs. Right shifted by Fs. So, if this is centered at origin, I will take the next one which is centered at Fs. Okay, so this is going to be how much? Fs plus 20, Fs minus 20. Okay, and then there will be another one at 2 Fs. Similarly, there will be one which is also left shifted to minus Fs, etc. Now, what is the next thing? An ideal low pass filter having cutoff frequency 37 is used to reconstruct MT from ST. This is ST. Okay, this is SF, which is the Fourier transform of ST. Okay, we need to construct MT, means MF. Okay, let me place the ideal low pass filter here. Okay, if you want to reconstruct, this is your MT signal, na? This is your MT signal. You want to reconstruct this much. This will anyways come because the cutoff frequency is 37. Correct, cutoff frequency is 37, which is more than 20. Okay, but what is important is the any other part should not come up. That means the cutoff frequency 37 should not be greater than Fs minus 20. So I'll play something like this. Suppose this is what is your ideal low pass filter. Okay, having the cutoff frequency of 37. Okay, which is greater than 20. No doubt the entire MF will come. Okay, MT will come. But at the same time, this cutoff 37 should also be less than Fs minus 20. Otherwise, what will happen? Okay, only if you want to reconstruct only, for perfect reconstruction, of only m, not more. Okay, any other term, any other frequency term coming up will lead to distortion, will lead to aliasing. Okay, so what is going to happen? This 37 should be less than fs minus 20. So fs should be greater than 37 plus 20, 57. Okay, so what is the minimum fs worst case? Okay, what is the minimum fs worst case? 57. Okay, option number C. Option number C. Option number C. Let me see the answers. Govind says C. Mani says C. Correct answer. Yeah, C is the correct answer. C is what is the correct answer for this question. 57 kilohertz. 57 kilohertz. Okay, option number C. Next question. A signal xt band limited to w hertz and yt is x cube t plus xt plus 1. What is the Nyquist sampling rate of yt? Now see, xt is band limited to w. That means highest frequency component is w. Okay, now see here. If a signal xt has highest frequency component fm, okay, or fm1, another signal yt, let's not yt here, suppose this is x1t, this is x2t, which has highest frequency component fm2, and when you add, because addition is happening, what is the result of addition? Okay, when two signals are added, the highest frequency component will be maximum of fm1 or fm2, whichever is higher. Okay, whichever is higher. Okay, similarly, if you had multiplied them, x1t into x2t, the highest frequency component of the resultant signal will be fm1 plus fm2, and when you convolute them, the highest frequency component is taken as the lower of, that is the minimum of fm1 of fm2. Okay, and product also leads to x1 power nt. If you take any power, okay, then fm1 plus fm1 plus fm term n times will come, no? So it is n times fm1. Okay, so if this has w, x cube 3 will have 3w. That's what. Okay, n times fm1. It will have 3w. Okay, so then what is the net fm for the signal is given by maximum of, because addition is coming, maximum of 3w or w or how much? Now, what is the highest frequency component for 1? What is the Fourier transform of 1? The Fourier transform of 1 is nothing but 2 pi del omega. It only contains an impulse at omega equal to 0. Okay, omega m equal to 0, or even fm is 0. There's only one single frequency, that itself is maxima. Okay, so 3w comma w comma 0, the maximum is 3w. Okay, and what is the Nyquist sampling rate? The Nyquist rate is given by, twice of fm. Twice of, what is the highest frequency component? 3w. So net answer for the question is 6w. Answer is B. Net answer is 6w. Okay, Nyquist rate, not 3w. Okay, maybe, yeah, Ricky correct answer. Okay, Govind correct answer now. Okay, Sai Vikas and Shanmukh, you have given the net fm, but I wanted a Nyquist sampling rate. So that is twice of fm. The answer will be B. That is 6w. That is going to be 6w. Correct? That is going to be 6w. Okay. Now, next question. Let xn equal to half power n un and yn equal to x square n and y e power j omega be the Fourier transform of yn. What is y e power j0? Okay, discrete time signal. Okay, y e power j omega, or simply you can call it as y omega also, is the dtft. Okay, where dtft is simply given by the formula summation yn e power minus j omega n. Okay, so if I am asking y0, omega equal to 0, na? See, that is what is the question. Y e power j0 means omega equal to 0. That is y0 is nothing but summation of yn. Is nothing but summation of yn. Acha, what is yn? Yn is x square n. Xn is half power n un. So yn will actually be, half square is how much? 1 by 4. 1 by 4 power n un. Now, either you can use the Fourier transform. Okay. So if you know the Fourier transform, then no need to solve the series also. Otherwise, it will be a series. Okay, for the signal yn, what is going to be the Fourier transform? Y omega 1 upon 1 minus 1 by 4 e power minus j omega. Okay, 1 upon 1 minus a e power minus j omega, a power n un dtft. A power n un has the dtft 1 upon 1 minus a e power minus j omega if mod a less than 1. Okay, then only the signal is absolutely summable. Mod a less than 1. Okay, so what is going to be y0? Okay, it is going to be how much? 1 upon 1 minus of 1 by 4. E power will become 1. Okay, so that is 1 upon 3 by 4, or be written as 4 by 3. Option number D, 4 by 3. Yes, correct answer. Manish, Shivsagar, Ruku Bitra, Sai Vikas. Correct answer D, 4 by 3. Okay. Next one. Okay. Now, if xn is 2 by pi and sine 2n upon pi n, okay, 2 by pi for n equal to 0, sine 2n by pi n for n not equal to 0, what is the energy of xn? Okay, energy of xn. See here, look into this question. What is the energy of xn? Be slightly careful here. What is going to be energy of xn? What is the signal xn first of all? Okay, let's simplify this. If I put 2n in the denominator, it will be written as sampling. It will become easy to write it in the form of sampling. Okay, but what is there in the denominator? Pi. Okay, so I'll write down, there is no 2, so I multiply by 2 and pi I separate. So see, 2 will cancel, it will be pi n only. Okay, that means my given signal x of n can be written as, okay, 2 upon pi sine 2n by 2n. What is sine 2n by 2n? Is sampling 2n. Now, at n equal to 0, remember, at n equal to 0, what is the value of sampling 0? Sampling 0 means limit theta tending to 0, sine theta by theta, and by L'Hospital rule, it is always 1. So, if you put n equal to 0, you get sampling 0, which is 1. Anyways, 2 pi will come. Okay, so both the conditions can be summarized by one single definition. Xn is 2 by pi, sampling 2n. Okay, but energy of the signal, okay, of such a signal in time domain, which is given by what formula? Summation minus infinite to infinite x square n, but is also equal to 1 upon 2 integral over 1 period modulus x omega whole square d omega. Once again, what? Parseval's. Because, okay, the summation of such a signal would be really tedious. Okay, if you think about solving summation of sampling 2n, sampling theta function would be tedious. You can use the Parseval's relation. What is the Parseval's formula in case of DTFT? 1 upon 2 pi integral mod x omega whole square d omega. Similar to CTFT, only thing is, because DTFT is periodic for period 2 pi, so only one period is sufficient to compute the result. Integral over one period. Now, what is the x omega? Okay, once again, the same result is applicable in DT as well, that sampling an has the Fourier transform first of all. Okay, sampling Fourier transform will be rect only. Sampling an pi by a rect of omega by 2a. That is the general formula. Okay, what do I have here as xn? Xn is 2 upon pi sampling 2n. Okay, so it will have what Fourier transform? Let me write down this x omega separately. Okay, 2 by pi multiply sampling 2n. Sampling 2n means pi by a. Pi by 2, a value is 2, rect of omega by 4. A value 2, no? So 2 to 4. Now 2 by pi, pi by 2 cancel. Answer is rect of omega by 4. Answer is rect of omega by 4. Rect of omega by 4, right? Okay, so energy, what is x omega? Is rect of omega by 4. That means if I wanted to draw this, it is going to be rectangle of width 4 minus 2 to 2. Width will be 4. Okay, energy by the Parseval's formula is now 1 upon 2 pi integral over 1 period. Now, what is 1 period? Acha, this is not the, this itself is exceeding, no, not exceeding, fine only, na? Correct, not exceeding, sorry. This is 2, okay, suppose this is pi and this is minus pi, this is 1 period. Okay, integral over 1 period, that is integral minus pi to pi modulus x omega whole square d omega, where x omega is a rectangular signal in the one period, and area under square of rectangle, you can use it as a square into d. You can use it as what? A square into d. So 1 upon 2 pi into amplitude square. Amplitude is 1 only here. 1 square into total duration 4 units. Okay, so net answer is 4 by 2 pi, that is 2 upon pi. Net answer is 2 upon pi. Answer is A here. Yes, correct answer, Sai Vikas. A. A is the correct answer. Yes, Mani correct. Ruku Bitra correct. A. A answer A. 2 by pi. Yeah. Okay. Yes, Shanmukh correct answer. Next one. The direct form structure of a FIR, finite impulse response filter, is shown in the figure. The filter can be used to approximate what? Low pass, high pass, band stop. Okay. So we'll have to first write down the input versus output relation. See xn, okay, which is, first amplified by gain 5. So what comes here is 5xn. Now unit delay means what is going to come up here is not 5, only xn is the input here. So x of n minus 1 further delayed by 1. So x of n minus 2, which is multiplied by 5. So you get 5xn minus 2. And then the output equation finally is how much? With the plus sign, you have 5xn minus 5xn minus 2. 5xn minus 5xn minus 2. 5xn minus 5xn minus 2. Five xn minus 5xn minus 2. Okay, so what is there? Y of n equal to 5 of xn minus 5xn minus 2. Okay, can we convert? Because type of filter means what type of frequency it is passing or blocking. So let's go to the frequency representation. Okay, so for frequency representation, we'll apply Fourier transform DTFT to both the side. Y omega will be how much? 5 xn x omega minus xn minus 2 time shifting exponential term e power minus 2j omega phase term. Okay, so what is the frequency response of the system? Frequency response of the system is defined as y omega by x omega, ratio of output by input Fourier transform. When you divide x omega here, right side 5 I'll take common, 1 minus e power minus 2j omega or e power minus j 2 omega. Correct? Now, if I talk about low frequency, that is omega equal to 0. What is the system gain? H0 will be 5, 1 minus e power 0, 1. Okay, so 1 minus 1, 0. It cannot be low pass filter. It is actually blocking the low frequency. Okay, when I go for high frequency, that is omega equal to pi. What is the high frequency in discrete domain? Is pi. Okay, h of pi, 5, 1 minus e power minus j2. Minus j2 pi is again 1. You can solve by cos theta minus j sin theta. Okay, cos 2 pi 1, sin 2 pi 0. So 1 minus 1, again 0. It cannot be high pass also. It is also blocking the high frequency. 0 gain. Okay, then we take some mid frequency MF. Okay, let's take the midpoint exactly. So when I try at the mid frequency, h of pi by 2 will be how much? 5, 1 minus e power j. Omega is pi by 2. The net answer will left here will be pi. Okay, and that is going to be 1 e power minus j pi is minus 1. So 1 plus 1, 2, 5 into 2, 10. It is passing some intermediate frequency. It has to be band pass. Okay, it has to be band pass. If I have to draw an approximate curve showing only the magnitude response, modulus h omega, okay, it starts with 0 and at the high frequency, it ends at 0. Okay, approximate. Magnitude spectrum is always even symmetric, identical to the left and right. Okay, this is what it is. And at the frequency pi by 2, the gain obtained was 10. Okay, like band pass filter, where you can say it passes a particular band of frequency with a with the higher gain. Okay, suppose this is some frequency omega 1, this is omega 2, this will be known as the bandwidth of the filter, where we can find the bandwidth by the 3 dB concept. Not required here. I mean, you know, those frequency where the gain of the system is how much? At least greater than 10 by root 2, 1 by root 2 times of the maximum one. Max amplitude 1 by root 2 means power half. Half power is also 3. Okay, so that is what is the concept here. Okay, but we don't want. Yeah, you can use Z transform also. You can use Z transform also, no problem. If you use Z transform, okay, see, if you by chance use the Z transform of the signal, remember what is the DTFT and Z transform connection? Normally, what is Z transform Z? R e power j omega, but DTFT is calculated on unit circle, mod Z equal to 1 or R equal to 1, Z equal to e power j omega. So when you use omega 0, low frequency, Z will be 1. Okay, when you use omega equal to pi, high frequency, okay, e power j pi, Z will be minus 1. And when you use pi by 2, e power j pi by 2, Z will be equal to j. These are the values of Z you have to put. If you use Z transform, that is also okay. That is also okay. But what values of Z to put? These are the values of Z that you have to take care if you run it in Z transform. Okay, yeah. So correct answer, band pass. It is a band pass. Okay, next question anyways. Okay, the response of a linear time invariant discrete time system to a unit step input un is del n. The system response to ramp input nun would be how much? The system response to ramp input n into un would be how much? Okay, let's see this. Okay, now see here, the response of a linear time invariant discrete time system to unit step input. Okay, let us try to solve this in the Z domain only, it will be easy. Okay, suppose this is the linear time invariant, this is the LTI system given, okay, which has the transfer function h of z. What is the data given? To the input, which is equal to unit step input, xn equal to un. Okay, the response means the output yn is simply del n. Okay, what is the system transfer function actually is given by yz divided by xz. What is yz? The transform of impulse is 1. The transform of unit step signal 1 upon 1 minus z inverse. So when you solve this reciprocal of reciprocal, you will get 1 minus z inverse. This is the system gain, system transfer function. Now what is the system response, okay, to unit step input? This is the second scenario. Okay, now the response to unit step input, suppose I first solve it in the Z domain, the response is what? Okay, the input, the system transfer function multiplied by input. Okay, that is 1 minus Z inverse into input Z transform. What is the ramp Z transform? The Z transform of ramp signal is Z inverse upon 1 minus Z inverse whole square. Solving in negative power, you can solve it positive power also. What is the yz finally? 1 minus Z inverse, 1 power will can cancel. Z inverse upon 1 minus Z inverse. So let me write this way. It is 1 upon 1 minus Z inverse into Z. Okay, 1 upon 1 minus Z inverse is unit step function. Z power minus 1 comes because of the time shifting. Okay, this one is only unit step. If you will write unit step. But because of Z inverse, so it is shifted unit step signal, u of n minus 1. U of n minus 1. B answer. B answer. This question in time domain, if you solve, will be little bit more time consuming. So that's why I have solved it in the Z domain. If you try with convolution and all, little bit, more calculative, I believe. Okay. Yeah, then let's go for the next one. Yes, Mehak Gupta, correct answer B. If xn is 1 by 3 power mod n minus half power n un, then what is the ROC of the Z transform? What is the ROC of the Z transform? Easy one only. Only thing is for individual, know the ROC. What is the ROC of the Z transform? Okay, let's do it. See, a power n un. What is the ROC? Mod Z greater than A or mod Z greater than mod A. Then a power n, three important cases, a power n u minus n minus 1, left sided case ROC is interior of the circle, mod Z less than mod A, and a power mod n, okay, the ROC is between A to mod A less than the mod Z less than mod 1 by A. But this ROC is applicable, third case, only if mod A less than 1, otherwise there is no ROC. Okay. So let's do it. What is the signal here? 1 by 3 power n un, 1 by 3 power mod n. What is the ROC for this? 1 by 3 mod A less than 1, na? Yes, the ROC will be A to 1 by A means 1 by 3. Reciprocal becomes 3. So there is one ROC 1 by 3 to 3. Okay, then half power n un. Okay, ROC will be right sided, that is mod Z greater than 1 by 2. Mod Z greater than mod A. Okay, now when two signals are taken together, ROC has to be intersection. Okay, the net ROC has to be the intersection 1 by 2 less than 1 by 3 less than mod Z less than 3. Intersection, common ROC you have to take, you have to satisfy both. That means you have to go in the common portion only. Mod of Z is greater than half. Okay, 1 by 3 to 3 and mod Z greater than half. What is going to be the intersection? See, write down the numbers in sequence. 1 by 3, 3, and then 1 by 2 will be here in between. You want 1 by 3 to 3 also, and you want greater than half also. So common will be half to 3, na? Half to 3 both will satisfy. Then mod Z less than 3. Okay, option number C. Option number C it is. Yes, correct. Ruku Bitra, Sai Vikas, Shiv Sagar, Mehak Gupta, Shanmukh, all correct answer. C it is. Okay. That's bit tedious money. That's why I have not taken it. Okay, just focus on Z in here. Don't try that. Okay. Especially when ramp is coming, don't try that. Okay, next question. Two systems H1n and H2n are cascaded. Okay, and the effective Hz is 4 upon 4 minus Z power minus 3. What are the values of A, B1 and B2? A, B1 and B2. Okay, when two systems are cascaded, see here, we know that in case of cascading, overall impulse response is obtained by convolution, or overall transfer function will be H1Z multiplied by H2Z. Convolution in time, multiplication in Z domain, correct? H1Z into the H2Z. Okay, now what is, okay, the transform for H1Z? A, okay, 1 upon A upon 1 minus B1 Z inverse, 1 upon 1 minus A Z inverse formula for A power n un. Okay, multiplied by, next one also has A, but 1 upon 1 minus B2 Z inverse. Okay, so what is the effective Hz that I am getting from the given data is A square upon 1 minus B1 Z inverse, 1 minus B2 Z inverse, correct? So I think there is a typo error in the question. It will be Z power minus 2 actually. Z power minus 3 at any cost will not come. Okay, yeah, definitely it has to be typo error. Let's take it as Z power minus 2. Now, I'll rearrange the given Hz. Okay, better to rearrange this way in the form of 1. So, you'll write it as 4, or rather, rearranging means divide by 4, write it as 1 upon 1 minus 1 by 4 Z power minus 2. Now, you see here, you directly only have Z power minus 2 term. You don't have any Z power minus 1. If you normally multiply, you will have 1, you will have Z power minus 1 and Z power minus 2. But only way if you want only Z power minus 2 term is B1, B2 equal. Because if B1, B2 equal, then how much you will get? Then how much you will get? Okay, it will be like 1 minus X and 1 minus X. 1 minus X and the other one. No, I think Again, another typo error that has come in the question, I think then. I think is another typo error, otherwise it will become square, then also z power minus 1 will come. I'll have to recheck the question, or otherwise this data would be a minus of b2 power n into un. I will recheck it once, okay. A minus b2 power n un. That has to be the another data. A into minus b2 power n. Otherwise options are there, na? Plus half and minus half, yeah. So that options will save. Correct. That is correct then. This part is correct. This definitely had a typo error. So what can I do if I want, because 1 minus x whole square I don't want, but 1 minus x, 1 plus x will be 1 minus x square. Then you can get this term. Okay. So you can, write power minus 2. You can write down this as a square upon 1 minus, or first let me write this way so that you understand. 1 upon 1 minus 1 by 2 z inverse 1 plus 1 by 2 z inverse. Got my point now? A minus b, a plus b, a square 1, b square 1 by 4 z power minus 2. Okay, now you have to compare here. Okay, so now when you compare, you will get how much b1? Okay, b1 will be equal to half. Okay, here it is plus half, that means b2 should be minus half. Okay, so half and minus half, that is obtained. Okay, what about a? A square is 1, so a has to be 1. Okay, a square numerator is 1, so a has to be 1 only. So what is there? Half and minus half, and a equal to 1, option number C. Option number C. Yes, correct answer, Sai Vikas, Mehak Gupta. I'm wrong. Some student. Option number C. Okay. Another question from Z transform only. Next one. The Z transform xz of a real and right-sided sequence has exactly two poles, and one of them is z equal to e power j pi by 2. And there are two zeros at origin. Okay, there are the two zeros at origin. If x1 is 1, which of the following is true? Real. Okay, whenever, okay, you have a real signal xn, okay, for any real signal, okay, complex poles or zeros applicable to both, here it is pole, complex poles, if any, okay, will always occur in conjugate pair. Will always occur in conjugate pair. And the data also says exactly two poles. Okay, exactly two poles. Oh, yeah, I remember, Ritvik Teja, you came to meet me on institute once. Okay, you messaged me in the group. So yeah, that's great. 65 in double E gate is going to be a good rank for you. Okay, 65 in electrical is going to be a good rank for you. Under 100, or not only under 100, I'm telling worst case, probably it might be under 60, under 70 usually. Okay, so, or worst case under 75. That's a good rank, and it's also good that you qualified in ESC prelims. Yeah, if you're in Hyderabad, you can come and meet me again. Right now, I'm not in Hyderabad, but maybe somewhere in this month, I might go to Hyderabad. So you can, if you are there in Hyderabad, you can come and meet me in the institute again. Okay, anyways, yeah, good one. Let the results come, then I'll congratulate you in a better way, but it's going to be a good and favorable result for you. Right. Okay, yeah. Let's do this. Okay, so what I'm telling, it has exactly two poles, but complex pole. This one is a complex pole. Z equal to e power j pi by 2. Because it is a complex pole, its conjugate will also occur. And what is Z conjugate? E power j theta conjugate, e power minus j theta. Okay, so this is another pole automatically. And there are only two poles. Okay, there are only two poles. So what is going to be the denominator term? Denominator z minus, see, e power j pi by 2 we can calculate also. Okay, rather what is this e power j pi by 2 will be j cos pi by 2 and j sin pi by 2. This will be minus j. So what is the exact denominator term can be written as z minus of j is multiplied by z plus j, and that is z square minus j square is minus 1. So denominator has to be simply z square plus 1. Denominator has to be z square plus 1. Okay, z square plus 1. Okay. Now, acha, what is going to be ROC then? I think only this much can conclude the answer. Okay. What is the ROC? Okay. For either of the pole, what is mod z? Magnitude of j is 1. Okay. So ROC has to be mod z greater than 1. Why? Because right-sided sequence. Right-sided signal xn is given. The ROC has to be exterior of circle. Okay, so z square plus 1 with mod z greater than 1 is only in option number D. That's it. Okay, this much alone is enough to say option number D. Okay. All right. So yeah, Shanmukh and Mehak Gupta, correct answer. D answer it is. Okay, now if you want to solve it fully, what else is there? Okay, there are 2 zeros at origin. Okay, 2 zeros at origin. So 2 zeros at origin means z square. Denominator I already got to know. And some constant multiplier, some gain may be there k. Kz square upon z square plus 1. Further what is given? X1 equal to 1. That means at z equal to 1, answer should be 1. Okay, so solving this, get k equal to 2. Okay, because if you put 2 into 1 by 2, then you will get answer as 1. K equal to 2. So 2z square upon z square plus 1. Completely satisfied. Right. Next one. Yeah, the 4-point DFT of this given sequence. The 4-point DFT of the given time sequence. Okay. Now see, normally if you have to find out the entire DFT, I think here it is not required to find out the entire DFT. Why? Because see, if you have to find out the entire DFT, 4-point DFT is given by the formula summation from n equal to 0 to n minus 1, that will be 3 here. Okay, x of n, w power, w4, twiddle factor, w power kn. Okay, or this is coming up as this way also, n equal to 0 to 3, x of n. Okay, what is wn? That twiddle factor is generally given by e power minus j 2 pi by n. Here it will be e power minus j 2 pi by 4 into kn. Okay, but simply remember that x of 0, whenever you solve, x of 0 is always summation of xn. Is always summation of xn. Whenever you put k0, w power 0 is 1. And summation of xn means how much? 1 plus 0 plus 2 plus 3, and that is equal to 6. Okay, so either out of option C or D. Okay, and then x of 2, okay, for k equal to n by 2, central ordinate. First ordinate and central ordinate. Central ordinate is always and always given by summation 0 to 3 minus 1 power n into xn. With alternate plus minus it will be solved. Okay. You can even take that complete twiddle factor matrix. I am telling you not required. I will tell you that also, but here not required. Okay, minus 1 power n, minus 1 power 0 will start at 1, then or minus 1 power odd, minus 1 power even, plus 1, the alternate plus minus. So if you start with 1, then minus 0, then plus 2 and minus 3. See, this much is how much? 3 minus 0. Now you see here 6 and 0, the central ordinate 0. Okay, so only by this much you can comment that the answer is how much? D, I think, right? Answer is D. Only by this much you can comment. Sometimes or many a times this can happen in MCQ. Otherwise, if you want to solve it fully, how we normally do, okay, the DFT x0 twiddle factor matrix, x0, x1, x2, x3, the 4-point twiddle factor matrix. Okay, first row all ones, that is what all summation. Third row is alternate plus minus. Second row is 1 minus j, then sign change minus 1 plus j. Fourth row is always conjugate of second row. The conjugate means minus j will be plus j will be minus j multiplied by the given signal. What is that given signal? 1023. 1023. Now when you multiply, you see the result here. First row, okay, how much? 1 plus 0 plus 2 plus 3, that is 6. Okay, then second row, 1, 0, minus 2 plus 3j. So 1 minus 2, minus 1 plus 3j. Okay, then third row, alternate plus minus, that is anyways we solved 0. And the fourth is nothing but conjugate of this second. So minus 1 minus 3j. Okay, this is the full calculation, and that is why minus 1 plus 3j, minus 1 minus 3j has come. But that was not required, I am telling you. So sometimes, always if it is a direct DFT calculation, 4 point or any point, first and central ordinate. Always try with this if your option matches at least in MCQ question, and BARC means only MCQ will be there. Na? So then, you can save a bit of time. Right. What is your next question here? Okay. The first 5 points of the 8-point DFT of a real valued signals are given. Rather, not only first 5, it is typo error. First 6. The first 6 points and last 2 points are asked. 8-point DFT means 8 points. First 6 are given, last 2 are asked. Okay. Now for DFT of any real valued sequence, any n-point DFT of a real valued sequence is conjugate symmetric in nature. Conjugate symmetry, which says that any xk is also equal to x of n minus k conjugate. X of n minus k conjugate. Okay, actually, the actual conjugate symmetry property, you know how do you write actual conjugate symmetry? X minus k conjugate, but because x of n minus k will be same as minus k plus n because DFTs are periodic. So, what are the last 2 points? The last 2 points, okay, will be x6 and x7. What is x6 by the conjugate symmetry? X of 8 minus 6 whole conjugate. Okay. Now, what all is given? Let me write down in the sequence actually. What is given? The x0, the first one is 5. The first count starts with 0. Okay. Then x1 is given to you as 1 minus j3. Then next value will be x2, which is given as 0. Next value is x3, which is 3 minus j4. Next value will be x4, which is 2 plus j4. Next value will be x5, which is 3 plus j4. Now you see, even if they have not given the third value also, this x5, this sixth value also not required because this is nothing but conjugate of 3 minus j4. Okay, because as I told you, x5 will have to be conjugate of x3, 8 minus 5. So even this was not given, then also no problem. Now last 2 point, x6. x6 should be conjugate of x2. 8 minus 6 will be 2. That means it should be conjugate of x2. What is x2 given to me? 0. 0 conjugate will remain 0. x7. 8 minus 7 is how much? 1. It has to be conjugate of x1. It has to be conjugate of x1. What is x1 given? 1 minus j3. So conjugate 1 plus j3. Okay, the answer respectively 0 and 1 plus j3. 0 and 1 plus j3. Option B. Correct answer, Mehek. Option number B. 0 and 1 plus j3. Okay. Recheck it, Govind. It has to be B option. 0 and 1 plus j3. Okay. Next question. Suppose xk is the 6-point DFT of xn 4, 3, 2, 1, 0, 0. Where and yk is the 6-point DFT of yn given by w6 power 4k xk, where w6, the twiddle factor, is defined e power minus j 2 pi by n. Which of the following represents yn? Okay, xn is given and the relation between the DFTs is given. The relation between the DFTs is given. Yk, w power 4k xk, w power 4k into xk. Okay, so let's do it. What is there? W power 4k into xk and w power, see, we can also write down this relation this way. W6 twiddle factor, if you expand, e power minus j 2 pi by 6 into 4k xk. Okay, or you can also write it as e power minus j omega k, noting that omega k is the discrete frequency which converts the dtft to dft, 2 pi by n into k. Okay, 2 pi by n into k, right? So e power minus j omega k into 4 times xk. Okay, so there is in the Fourier transform there is an exponential term, phase term, that happens because of time shifting. What should be yn? E power minus j 4 omega. So yn should be x of n minus 4. Okay, time shift property of DFT. Time shift property of DFT, x of n minus 4. Now, because DFTs and IDFTs are periodic, okay, what type of shifting is followed? Circular shifting, circular right shift. Okay, so xn is given to me. Let me write down the given data. Xn, n minus 4 mod 6. The length is 6 here. The length or the period of the signal is 6. Okay, modular shifting. Now, what is xn given to me is 4, 3, 2, 1, 0, 0. Okay, now what is x of n minus 4? Normally, what do you mean by x of n minus 4? Is right shifting. But you have to write down for periodic signal results only in one period. Okay, from 0 to n minus 1 within this bracket. Okay, so can right, if it was linear shifting, you go to the right. But since you cannot go to the right, any value going outside will circularly move and come here. Okay, you have to do this 4 times. So what is going to happen? The last 4 samples will come to the beginning, 2, 1, 0, 0. And then, see, this is 4 place right shifted. This is 4 place right shifted, but this guy cannot go outside. Na? Okay, that is what. So whatever value should come up here, 2, 1, 0, 0 will come to the beginning. This is what is circular shifting. Okay, so answer has to be 2, 1, 0, 0, 4, 3. 2, 1, 0, 0, 4, 3. Answer is B. Answer has to be B. Correct answer, Mehak Gupta here. Or I think that is the answer to previous question or what? This one. Okay, again is B. 2, 1, 0, 0, 4, 3. Circular shift. Okay, modular shift, circular shift. Okay. Now, yeah, so this is the next important update for all of you, that in case you were planning to join offline and you could not join our first batch, and if you really want to join GATE 2027 batch in the offline manner, in a physical manner where you can interact with the faculty instantaneously and you are sitting in a competitive atmosphere, because physically many people are sitting and fighting for the same dream as you have. Okay, you can join our next offline course that is going to start on 10th of March. And if you are decided, don't delay, because early you join, early you complete the syllabus, more the time you get for revision and test series, right? So the batch starts from 10th March, and the fee, the current discounted fee is 56,500. Of course, there are some special discounts as mentioned for NIT, IIT or old OHM students, and also for triple IT and government college students, very clearly mentioned here. Okay, so you can take the benefit and walk down to our Hyderabad center located at Kothapet. Okay, I'll share the address also. The batch is available for both EC and EE. Okay, but in case if you are college going and you cannot at any cost take offline right now, then, and it's still, if you want the similar content by the similar faculty team, you can join our live course. Okay, online live course. So since it is live, you can have again the instantaneous interaction. It will give a sort of a similar feel to offline, but not the real one. Okay, so but yeah, if it is possible, you can walk down to Hyderabad. Okay, for more effective preparation. But at the same time, if you want to do it at your place, at your convenience, you can join our online course. Okay, starting from 9th of March. The next online live course starts 9th of March. Okay. The fee, it is available for both GATE 27 and GATE 28. The fee for 1 year, that is for GATE 27 program, is 99.99. For 2 years, it is 28,999. Okay, so you can also prepare through this particular course, as many students do, right? Okay, so this is how it is going to be. Yeah, so and If you're also willing to prepare for, if you or your friends are targeting AE examinations, especially the power sector examinations of Telangana or Andhra Pradesh, Genco, Transco, Discoms, the new offline batch, okay, just started 27th February, okay, and very soon new batch will also start. That will update you, but you can also join from this particular batch. Okay. Yeah, that's it. So this is the center for our Hyderabad center. As I told you, we're located at Kothapet. For any doubts or any queries regarding to the course, you can contact 95156940053 and our team will guide you regarding any doubts you have regarding to our course or gate preparation. Okay, this is our institute main website, ominstitute.com, and if you want the information about our live courses, www.ominstitute.live is what the page. Okay, this is our official Telegram handle, and if you want any personal discussions, like many of you are asking about rank and possibilities, you can connect with me in my Telegram group, which is mentioned here. You can search using this link, you will be directed to my group. And also the PDF of today's session, like I shared the control system PDF, the PDF of today's session, I'll share it in my Telegram group. Yeah, but again, as a procedure, the PDF will be password protected. And what is the password? Last question was on DFT. Password DFT, everything in capital. The password for today's PDF will be DFT, all caps on. Okay, all capital, without any space, DFT. Please note down the password. The PDF will be password protected. Only the students with this password, I mean students who are dedicatedly preparing and watching the sessions and learning, they need the PDF. They can access it through the password DFT. Okay, that's it from my side. The password, the PDF up here. Okay, any more doubts regarding today's session, you can definitely mention it to me here. Okay, Vasudeva says IN paper 51 marks. 500 to 600 around. Probably can be below 500 or 500 to 600 types is what you can expect in case of instrumentation branch, right? Correct. Yeah, I'm also getting some message in my Telegram regarding HPCL previous year papers. I think I have most of them. Okay, I'll consolidate, I'll combine, and I'll share it in my Telegram group once. Okay, in 1 or 2 days, I'll share all HPCL PYQs. Okay. Okay, dear. Thank you. That's it for the session. Bye bye. Stay safe and take care of yourself.